is your GSP ones, which is very focused on the work that test programmers do. Uh, I know from my last company and the current company is very SAS focused. Sometimes that's all it supports, so a single proprietary language. And there's a lot in there, which I guess would make someone coming from the data science school a little bit queasy. So you often had code, which was maybe written 20 years ago. It is still being used. They've gone on some very, very strange development journeys over that time in terms of how this code's evolved. And you see things like, and I understand this is a pattern common across a lot of companies where Excel is kind of your metadata repository. So there's a lot of kind of study-specific metadata that's being stored in tools like Excel. And then you often have secondary platforms that's more of your exploratory SCE. I think for a lot of companies, R was one of the reasons that these SCEs got created in the first place. And, by nature, they tends to be multilingual, so they often support Python, but as well as the proprietary language. But I guess one really core and fundamental difference between these two platforms is usually the GSP SCE has a lot of abstractions. It's a very process-driven and controlled environment, whereas the exploratory SCE tends to be a lot freer. People are kind of able to modify how they use the platform, and there's a lot less kind of forcing people into a single way of working. But as you can imagine, it is often very annoying to have these two different platforms. So it means you kind of got double the training. You often have to work across the platforms, which causes its own issues of moving data around, or different people in the department using different tools. And overall, it's just not a scenario that we want to kind of take forward into the future. This might be something everyone knows. I don't know what the spread of the audience is, but there are kind of three generic roles. I know we have statisticians in the audience, so please, I realize these are generalizations, not to take offense. But statistical programmers, they tend to be more focused on kind of executing pre-specified analyses. So a trial may have 600 deliverables that need to be generated, and the statistical programmers had to, as efficiently as possible, deliver those deliverables. Statisticians are kind of straddling two different worlds, so they are involved in these pre-specified analyses, but they're often doing ad hoc exploratory analysis. And when you move into topics like trial design, they might be using new tools or having to kind of adapt and use new methodologies study to study. And then if we start to talk about bringing the entire department onto a single platform, we might be more likely to get things like omics data, so bioinformaticians come into play, or there may just be generic kind of data science work happening within the department. And there's much more of a focus on agility and the ability to kind of modify how people are working to suit that particular project, as well as much bigger volumes of data. So going back to my days supporting crystallized healthcare, trial, it may be maximum a terabyte. You're more likely talking kind of 100 gigabytes of data. When you start talking about some of the analyses going on where you're saying, hey, this particular study, we've got 5 terabytes coming in or more for a single analysis. So you need an environment that can run this, and also the high compute. So I know things like spatial statistics, the generating those kind of spatial statistics on images, you could be talking about $4,000 or $5,000 for a single run of the script. That's based on the kind of quantity of data that needs to be processed. How they work is also often different. So for a statistical programmer, you're probably going to get by just giving them a studio or test studio. As statisticians, maybe using some different tools. They might be more likely to adopt things like Shiny. And then when you start talking about data scientists, you may have particular data scientists who are collaborating with academics using Cromwell, or they're using Airflow, and they want to go to run those pipelines internally as well. So there can be a lot more diversity present, and also sometimes the expectation to be able to build their own workspaces. So how the software ends up kind of playing out within the departments is we have at GXP scientific computing environment. It's locked down. It's often not updated very often. It might be on a 6-month release cycle or something like that. And this is where those pre-specified analyses are done. There's a batch run, which then generates SCGM, ADAM, and all those deliverables that are required for the study. And this is a validated process. often though people want to kind of collaborate with these teams. And so you had data then moving across into the rest of the department SCE, the exploratory SCE, or whatever it happens to be called within that company. This slushy is a term at GSK first mentioned at Fuse 2 years ago. But it's an idea that it might start from those kind of frozen environments. There's a lot more flexibility for users to modify them. So they can update packages, they can install additional things and stuff like that. So it's more of like a slushy platform rather than a frozen platform. And there might be tooling within that platform to do batch runs again, but often this is an unvalidated process. So those outputs are not considered to be validated. I think what we want to kind of move closer to is having a single unified scientific computing environment. And one of the ways to achieve this is to kind of isolate out what actually needs to get validated. So if we think about kind of the development of your code, yeah, validation might not be as important. Decisions aren't being made on this kind of iterative work that's happening to develop things like the TFLs, so the tables, listings, and figures. And you can give people more flexibility here. And instead of kind of trying to validate the entire platform, focusing more on the thing that needs to get validated. So if we're talking about a GSP output that's used for decision making, what really matters is what data went into that, what code went into that, which environment was used, and I'm isolating it down to focus just on that one kind of output generation happening non-interactively, because I think it's very difficult to robustly do something interactively. So this non-interactive run, it generates a validated SCCM atom or a table figure. And I think this is the model we're kind of trying to move towards, where we have this kind of more free and open environment. But we talk about prod run, a production run, or a batch run. There we can lock things down and make sure there's that reproducibility and replicability present. So I think the benefits to users are hopefully quite obvious there. It means we have this consolidation. So now we're able to handle the more diverse types of work happening within the same SCE as the more controlled and generation of GSP outputs. And we can also harmonize training. So it's not like we have two completely separate platforms, depending on what role the person has. And yeah, this allows our kind of users to use the tools that they want to use and to develop their code, and knowing that they can make sure that the GXD outputs are generated in a way which is meeting all the kind of requirements from regulators, as well as our internal policy and compliance case. So as a second element, which kind of helps bring our whole department into a single SCE, is this idea of focusing on the abstractions. So we have one kind of common platform where we can change the abstraction present depending on the particular role and the particular expectations placed of that analysis. So if we think about efficiency and speed, you can have abstractions set up a project. So you can make sure that it kind of is structured a particular way for a particular type of work. From the compliance side, we can control the QC process. We can make sure the QC is done a particular way for particular types of work. And I mentioned before the production runs, but we can still have that flexibility. So not all users are going to need these abstractions. Some users may be able to go down straight to the core Domino platform and work from there. And then I think one final piece that's important to flag is that these abstractions also help us to maintain kind of a fair platform. So we can kind of enforce the collection of certain metadata around what's going on in the platform, making it more discoverable. So there was a talk, which is, I don't know if the slides have been shared, but there's a talk here by J.D. Long. We gave a keynote talking about abstractions as kind of one of the main tools we can use when building platforms. This particular example, I think, was more about R packages. It carries across the SCEs as well. And I just want to repeat some of the assertions JD made in that keynote. So this first one's not actually related to my talk, but I think it's an important point. As just to flag that, the business doing data science is actually a really good thing. If you think of the ways we could have gone, you could have had people writing code from something like Novartis organization for the entire company. Well, what we see is data science and with the writing of code happening by the domain experts. And then I just want to flag, that's something JD mentioned, and I think it's a really important positive things that we have. Kind of going on track a little bit. When we build these abstractions, we need to make sure that they're not a black box. So if we do build this tooling on top of Domino, we need to make sure that it's permeable to the users, why it didn't work. Like if there was some expectation and that wasn't met, it should be clearly communicated to the users. And another thing he was talking about was that 80-16-4 rule. So for many of our normal business users, we can build these abstractions and to make their lives easier. There's going to be super users. Sometimes this might be super roles. So it could be particular groups within the departments are doing more advanced stuff, or they want access to, they want more control over their own way of working. And then you're always going to have those gurus. So those people really pushing the platform as far as it can go. And so we need to build an SCE. If we're going to build an SCE for the whole department, we need to build an SCE that's works for everyone in that graph. So to kind of give some more tangible examples of what we're doing, so Domino has this native project creator. So if you're talking about data science, it's a great tool to use. You can go in, you can manually enter information and create a project, attach data sets and stuff like that. But if we start talking about those kind of pre-specified GXP analyses, this is where we need to build our own tool to make sure things are done in a certain way. So an example of that is we have our own abstraction on top of the project creator, which kind of forces people through a particular way of structuring their projects. So I think another example is Domino flows. The Domino flows and the things based on flight is a really powerful tool, which is great for orchestration. It's also really complicated. That's an actual flight composition file, and they're kind of confusing. Like if you don't know Python, it's even hard to read what's going on because it's based around Python classes. So one thing that we could do there is, I've got training management leader sitting in the audience. I think if I told her, hey, we need people to manually create these flight files, she's not going to be very happy, and the users are not going to be happy. So this is where we can build an abstraction. So for these particular users, like statistical programmers, we can build an abstraction that simplifies the process. And it also allows us to integrate. So if we talk about those 600 deliverables, those exist upstream BCE. Like we know what they're going to be because we had the mock shells that were generated. So then we can start kind of plugging in and making people more efficient because we could pipeline this information through into the orchestration. So this is kind of an example of the kind of core process that we're following. So built into Domino, we have flows, and we have the ability to attach data. We can attach code like the Git repository, and we can attach compute through the workspaces. And as I mentioned before, some users, they may be using this directly. So some of them are power users, may be directly going into these kind of core tools that come out the box with Domino. But if we start to talk back on the core recording, we want to bring in controls, we want to bring in efficiency. This is where we can start adding our abstractions. So as I mentioned before, put example of the CSR projects. These are the ones going into our filings. We can create that project creator I showed on the earlier slide to kind of control the process. And behind the scenes, it's running those Domino. It's creating a project using Domino's APIs. And as I mentioned before, one of the great things about the abstraction is that we can also improve both the fair side as well as making sure things like assistance. So in this particular example, upstream of our SCE, we have an operational database with stuff like clinical project IDs, and over here, metadata. And because we're using our abstraction to create the projects, we're able to inject that information. So it links up and it means it's connected across other work happening outside of the SCE as well. Yeah. So another example is the GSP prod runs. So I mentioned before, we have the planned deliverables for a particular study, which says, that work is happening in front of the STE. And so we want to get to the point where these are being executed by Domino flows. So we need to build that middle step, the abstraction to handle the deliverable lifecycle, and also like to pipe this information through so that they can be executed. And I think this is an example where, and I mentioned earlier today, we're actually probably going to replace our abstraction with some of the core functionality that comes to the Domino that's being built specifically for SAS programmers. So yeah, in terms of a path forward and a bridge, this GSP and non-GSP divide that we've had historically, one of the really important things is to kind of focus on what actually needs to be validated. So where do we actually need to put in this control, knowing that we're going to have, if we're going to have the whole department on the SCE, we'll have people come along and say, hey, I lead PyTorch and I lead it by Monday to start a new project, and we need to be able to provide that to them. So how can we do that in a way which is still enabling very, very robust, transparent, traceable work to happen on the GSE side? I think one thing I learned from my prior company was also just getting aligned with quality and compliance on what we're talking about in the first place. I'd probably say there was maybe about 5 or maybe 10 hours of meetings in before I think we were even talking about the same thing. So a lot of these topics, people will straight away jump to be very risk averse, and it takes a lot of kind of talking and working with quality groups and compliance groups, make sure that we're all understanding things the same, and then we can start to talk about, well, actually it's okay, we give certain power users with a little bit of extra training the ability to create their own workspaces. I think that's an example where, if you talk to someone from policy, hey, we're going to let people make Docker files, they'll freak out. Non-qualified, non-validated Docker files, and if we start to walk through and really make sure we're on the same page, understanding why they're doing this and why it's probably okay, you can come to a very different conclusion. And yeah, as I mentioned through the talk, I think abstractions are probably the most important thing. Like as the product owner, we have this base general data science platform, Domino. So our job is the abstractions. Our job is putting these layers on top to make it all more efficient, make science more robust, but not to nerf Domino. So we still want Domino to be there for the power users. Yeah, and as I mentioned before, I think this is a requirement to kind of have your bioinformaticians and your imaging scientists and the like sitting in the same platform as a sole programmer. And so, one of those really annoying people that cite themselves. So we haven't released our SCE yet, but I mentioned before I worked for Merge before, and this is in production there. So I think one of the best things that came out of our last SCE, the last SCE I worked on, is we managed to get the amount of the SCE validated down to a very small piece. The vast majority of the SCE, we could do releases on demand. We were quite free to adapt. It was only when we started talking about data access or prod runs, and we started getting into kind of a really locked down part of the SCE. Yeah, so I think as some kind of summary, the unified SCE, I think it helps unlock innovation while still allowing kind of compliance to be in place. Abstractions are kind of the key things to make this happen. And I think it's really important to try and focus on what parts of the SCE do we need that control, and do we need to go through the process of full validations.